Okay.
Okie dokie.
Okay, well, I can go ahead and say prayer.
Okay.
Our dear Heavenly Father, we're grateful for this time that we have to come here together and to study more about this pre-calculus course. Father, we ask you to please bless us that we may be able to be enlightened and be guided for how we need to study and the things we need to learn for this course. Father, please bless those who are unable to make it tonight, that they too may be diligent in their studies and continue to have success in this course, and that we may go through in this and all of our classes and be able to find success with thy help. We're grateful for all that thou dost for us, Father, and we say these things in the name of Jesus Christ. Amen.
Amen.
Okay. Oh, my head is pounding.
Oh no. Okay.
Am I on? Instructions. This is the first hangout, right, of the week?
Yeah, the first hangout, yeah.
Okay.
Okay. Okay, team discussion. Begin by reviewing your solutions for question 1 through 3 from the preparation assignment.
I guess the cool thing that I did find from the preparation was well, I don't know if it means all of them or if it's just referring to these specific ones, but it says we didn't have to memorize some of the identities. So
Yeah.
I guess that's how, because I barely have the unit circle kind of understood, and this is going to happen.
Yeah. I don't know. Yeah, I don't know. I guess memorizing them is good to like make sure we can or like better understand what we're doing, I guess.
Yeah.
But like some of them, I'm just like, do I really need to memorize that?
Yeah, or if you get some, usually you can kind of figure them out enough to get the rest.
Yeah.
Like for them. So I can see the benefit there to getting like half of them down, because then you'll probably know the other half if you got those.
Yeah, definitely.
Let's see.
Okay, preparation. It said 1 through 3. Where's my prep?
Did I just click? No. Why?
Oh, that's not what I wanted. That is definitely not what I wanted. Oh no. Wait. Week 10. That's the only problem about keeping notes this way is I tend to mix them up and kind of lose them.
Oh, yes. I found, I don't know if it necessarily helps. A lot of times when I take, because I take, my notes are kind of crazy, but whatever day I'm doing, like I'll write in the corner, I write the date and then I number the pages. So every day that I start new pages, it's a new date and a new page number. So they all usually go together from that day. It's kind of helped, but you have to remember to put the date.
Yeah, definitely. This is from week. It's not what I want.
But I guess I mean, I didn't have so much of a problem with it. I mean, I do like the PowerPoint. I have and I know this probably sounds silly, but I need to go and find or something, a review on fractions and like the denominator and numerator, that trips me up so bad. So I'm messing up on these problems whenever I'm getting like, whenever you're putting like square root of 2 over 2 over something, and
Yeah.
I'm messing that up terribly.
Yeah.
And I know I'm doing the right thing because I can like plug it into the calculator. It's the same value, but it's like I can't mathematically do it right.
Yeah, I had the same problem, honestly, and I like had to ask several different or a couple different questions to several different tutors in the math center to straighten
Maybe
that up.
that's something I'll do, is go out to the math lab.
It is really nice, especially since like this is online. I don't really have somebody in person to like physically explain and walk me through the problems.
Uh-huh.
Uh,
Yeah, that's my hardest part, is I'm not getting those. And you try to Google help for that and it doesn't really get you anywhere either. But
yeah,
maybe I'll go to the math lab and just see if they can explain it a little bit better.
yeah, it's really nice. Okay, 1 through 3, product identities, blah blah blah. You just plug them in. Yeah, that
Yeah.
one's pretty straightforward.
Yeah, I didn't have a problem with those. Um, let me see. Rewrite the following expressions in product sum or sum to product. Yeah, those ones I didn't come up with a problem. Number 3, the second part of it, I didn't come up with the value, but I think I'm getting tripped up again with the fractions with that one. But can we I know we can't take like the tests or anything or whatnot, but can we take like this part of it to the math lab? Like, is that okay to take there?
Oh yeah, yeah.
Okay, because
Well, I'm pretty sure I've been doing it this whole time.
okay, yeah,
'Cause,
because I know I always see like the don't take this or
yeah,
whatnot.
this isn't necessarily graded. Like our preparation and our extension problems work. It's just for like practice and just to see if we understand what is being taught, I think. And so if you don't understand something, I think it's perfectly fine to ask somebody else who does understand and have them explain it to you until you do understand it.
Okay, okay, that makes sense.
Yeah.
But yeah, I didn't have a problem rewriting the expressions, but finding the exact values, the second one kind of tripped me up a bit.
What part were you tripping up about?
Let me see. Like 50 pages here. I need to write in actual lines. I write like across the page. But I couldn't figure out. Well, I guess that's just a matter of like I said, I have a bunch of like I feel like I have the questions that you shouldn't have questions about. But like whenever it's like sine of 75, that's you're using like sine of 45, or you like you're getting that by subtracting other angles that correct? If that makes sense.
So like so you're saying sine of 75 is I'm not quite 100% sure about what you're asking. I'm actually
Well, because that makes like sine of 90, right? When it's added together. Well, and that's like, I don't know how to describe what I'm thinking.
Yeah, I gotcha. So when you have a sine plus a sine of two different angles or degrees or whatever, you have to use the sum product theorem right here, which is
Okay.
this.
Okay.
Yeah, you can't just like add them together, apparently.
See, that's what I was confused with. Because whenever I went into the book and one of the descriptions, and I don't know if it was a sum to product identity, where it was telling me to you subtract it from whatever, like the biggest, I can't describe it, like wherever you could you made it fit the closest spot on the unit circle that you could, if that makes sense. It came out to the same value, but I didn't like the way the book was telling me to do it. And that I feel like it doesn't make sense whenever it's degrees like that.
Mm-hmm.
And that's where I was getting confused in the resources, because it tells you to do it this funky way, and I wasn't understanding, because instead of like, I guess like 15 degrees, you would do like 90 minus it, or I can't remember, but that's how you, but yeah, I couldn't follow along with that, but
Yeah.
okay. But no, I really might just make a run out to the math lab and not do it that way, because that way it makes no sense. I don't even know why it has it in the math in the textbook, but anywho.
Yeah, definitely.
Alrighty. Apparently, it didn't want to show me the invite, so that was cool.
Oh no.
Sorry.
That's all good. I was just sitting there waiting because normally my inbox updates constantly, but it didn't want to do that today.
Yeah, we were just going over that first part of the hangout where it says to go over questions 1 through 3 of the preparation problems.
Okay.
Let's see. Well, did anyone else have any questions about the first, I think it's 1 through 3 from the preparation assignment?
No, I don't think so.
Preparation. It's 1 through 3.
Let's see. So, and then after we review the 1 through 3, it says to spend some time discussing question number 5 about solving.
Oh, here it is.
That one I started on, but I haven't finished number 5.
Okay.
I should have, but I didn't.
Do you have any like questions off the bat, or does anybody anything you want to discuss?
I think I'm all right.
Okay.
Yeah, if it helps, the fun part, I guess, about those, I did the sign and the first 2, and it's kind of cool because I mean you can just do the identities and solve it backwards. So maybe like on the test, if you ever want to like double check yourself, that's kind of what I was doing.
Yeah, that's cool.
And the resources. Okay, so number 3 on the instructions are from the resources. Learn how to write solutions for 0, 2 pi, and all solutions. Using the solutions from 5, write each solution as a solution set. Sorry.
Write each solution as in all solutions.
Here, give me a sec. If you want to get in snacks. Here, give me a second. Sorry.
Oh, good.
And the solutions, right? Each solution is a solution set. Okay.
Solutions. So is that just asking the one sec solve for? So I'm assuming it's saying this. Right. Okay. For x equals 5 or 6. Is that from what y'all understand? Is that asking for us to basically write like this thing for each of these problems?
I think so. Yeah, and see that's where I don't know. I guess maybe I need to just look at it some more, but I'm not 100% sure what it's asking of us.
Mm-hmm.
But I mean, it had us go through sine and tangent. Well, those are the ones that I did. But does it just want us to go through all of the functions and make a solution set for them?
I'm assuming, yeah.
But then what values between then are we trying to do, or is there just That's what I don't get. What is the value we're using with it? Because in the practice stuff, we found solutions, but it gave us a value, and this one isn't giving us a value. So I don't know how to find the solution in that range with no value.
Mm.
Oh wait, well, it's saying using the solutions, write it as a solution set. What's a solution set?
That's
That will
the X. The thing that I just showed you.
Oh, okay.
Yeah.
Okay, so then never mind. It's just asking us to use the same ones from that. I guess that's what I missed.
Oh, there it is. Okay. We have so then for this tangent. So then would tangent solution set look like this?
What is that last part?
K pi.
Let me see. Let me finish my end.
Okay.
See. Oh, my brain's not working today. What am I doing wrong? I don't know why mine isn't coming out right. Moving on. I don't know what I'm doing wrong with these problems.
What do you have so far?
Well, I'm trying to work it, but I'm losing. So do you add the pi k before you divide it?
I think you're supposed to divide before you add.
Or do you divide before you add?
You're doing
I was trying to do the tangent.
the tangent is equal to 1 over, or negative 1 over square root of 3.
Yeah.
Okay,
Oh, my head's not working today.
here's what I got. Starting right here, I have tangent, which is also that equals that. That just helped me picture it better, kind of. But you basically just take the inverse of that, and whatever angles that has, whatever two angles that has negative square root of 3 over 3 as their tangent would be these two angles. And then these angles are like within
the 0 to pi.
Yeah, so we have 5 pi over 6, which is here. And then we have 11 pi over 6, which is this angle plus pi, which moves it all the way down here.
Okay.
And so what I did is I put the x, line x, equals this angle, and then k as the however many times you want to do it around the circle times pi. So it's this angle and this angle, and however many times you go, whether it's negative or positive pi, you'll always get either this angle or this angle, or you'll always get this angle if you take this angle. Does that make sense?
Okay, a little bit. I'm seeing where you're coming from.
That's just kind of how I understand it. Yeah.
Okay.
Do we want to try one of those reduction theorem problems before we have to go?
Sure, I know we gotta go in a little bit. I gotta go. I apologize, guys. I know I'm not feeling well at all today.
No problem.
Okay. Okay. Find the part of reduction theorem. So rewrite it and then solve for it. Okay. I'll have to rewrite it with the reduction theorem.
Reduction theorem.
I've actually got to go, guys, or else I'm going to be late. So,
Okay.
but I guess just I'll see you in the text group whenever I'm meeting next.
Okay, sounds good.
See you guys.
Yeah.
Yeah. Okay. A equals. Okay. Once. Sine. Sine square root of 3. Sine. Negative sine. Where's my thing? So would that be sine x 7 pi over 6? Or am I not even in the ballpark?
Which one are you doing?
On the reduction theorem?
Like which one? Why?
The first one.
Okay, the first one.
Yeah, I don't know if that's what.
So here's what I got. So we have. I kind of did things a little weird, like in a weird order, or I like wrote them in a weird order. But so we have the original equation right here. What did I do?
Yeah, yeah. See, I got negative sine x plus 7 pi over 6, and I don't think I was looking at the right.
Okay, so
part
what
of
you
it.
do? So you take. So this is essentially a plus b, or the coefficient in front of this term is a and this term is b. So we have a negative here, so that's -1, which is there. And then we have square root of 3, which is here. So it's -1 square root of 3 is where the thing is.
Okay, and that's for the terminal side of it, right?
Yeah. And so that puts it in quadrant 2 because it's negative and then up.
Okay, I got you that far.
And then you take the -1 and then the square root of 3, and you use the Pythagorean theorem to get that length, which is 2. And then we have this formula here. A squared plus the square root of a squared plus b squared is sine or times sine and then x plus the angle, theta. And so to solve for that, so this is the hypotenuse of this triangle. And we already figured out that that was 2. So I put the 2 there. And then the square root of... Oh, and so I just said that was the angle that we're trying to find. And so I took cosine because it was the simplest. So it's -1 over 2.
Okay. Over.
Which is this. And the cosine, and then take the inverse cosine of that. And you get 2 pi over 3. And then you put that into the finished equation.
Okay, see, I got 7 pi over 6, but okay, -1 over 2. Oh, okay. I looked at the sign of -1 over 2, and that's what gave me 7 pi over 6. I didn't look at the cosine of it.
Oh, okay.
Okay, but okay. I mean, but well, you did the cosine because, like, couldn't you do the sine as well, or?
You should be able to do cosine, sine, and tangent and get the same thing.
Why didn't? Yeah, see, and that's what I'm trying to figure out. Why didn't mine? Because I did -1 over 2, but the sine over -1 over 2. But unless I just got it wrong, because sine is.
Oh, you did sine.
So opposite over hypotenuse, but
no. So sine would be square root of 3 over 2.
3. Okay.
Because it's opposite over hypotenuse. Cosine is adjacent over hypotenuse.
Okay, I might have just gotten sine and cosine confused and took the sine of -1 over 2. Yeah, because that's what put me at 7 pi over 6. But if I would have done the cosine of that, okay, I see how you got the 2 pi over 3.
Yeah.
Okay. Oh boy. But okay, yeah, it's those little things that I trip up on them all the time. I've
done it so much today.
Right. Well, anywho, I got a jet. We got to be at the stake center, but
okay, we can finish.
I don't know if y'all still want to be on. I think I can exit and y'all can still be on, but I'm not sure how that works. I'm not really sure how the Google Hangout works.
I'm good. We can, if we have any other questions about this thing, we can talk about it next time we meet, probably.
Okay, sounds good. I don't know if everyone wants to meet tomorrow again, or if we want another day to kind of mull it over or something. I don't know. We'll figure it out tomorrow.
Okay. I won't be able to do Friday, or yeah, Friday I can't do, but I can definitely do tomorrow, but if we want to, yeah, I don't know. I guess we'll talk about it.
Okay, we'll figure something that works.
Yeah.